Here is the key and the walkthrough for Lab 4.2. Hopefully you've done the entire packet. This is to check your answers. If you're going along here and just copying, it's not really going to be very helpful for you. If you're truly stuck, then take a look at the example that we're going to be doing next and then try the next one on your own before going on to the following answer. So that's how I would suggest doing this to help you actually learn this material to the best of your ability. So to remind you guys, when an atom has a certain number of electrons, they just don't assemble randomly around the nucleus. They actually occur in these shells. The first shell has up to 2 electrons, the second shell can hold up to 8, and the third can also hold up to 8 as well. Also, your protons and your neutrons are located in the nucleus in the center. Okay, so that's where each of the subatomic particles lie. The electrons are around the nucleus, the protons and neutrons are in the nucleus. So we have 8 protons and 8 neutrons. Where do we write that? We write that in the nucleus, in the center. So we have our 8 protons, we have our 8 neutrons. Again, protons have a positive charge, neutrons have a neutral charge. Now, how am I going to get 8 electrons situated around the nucleus? The first shell can hold up to 2. So here's my first shell. I'm going to put my 2 electrons roaming around in that first shell. Well, how many will fit in the second? Well, up to 8 will fit in the second, but how many do I have left? I have 8 protons, I have 8 electrons. 2 of my electrons of my 8 fit in the first shell. How many will fit in the second shell? 8 minus 2 will give me 6 electrons. So my 2 electrons in the first plus the 6 will give me my 8. So it's not going to be 4 and 4. We don't split them like that. Only 2 can fit in that first one. Let's take a look at sodium. Sodium has 11 protons. So again, protons are in the center in the nucleus. The neutrons are also in the nucleus. I've thrown in sodium because, first of all, it's going to have an extra third shell, but also because protons do not need to equal the neutrons. Here's an example. Actually, the higher that you go on the periodic table, the more irregular that the protons and neutrons become. But that's something we learn in chemistry. So let's go ahead and situate our 11 electrons. How many fit in the first shell? 2 electrons. How many will fit in the second shell? Well, I can fit 11, so I can fit a maximum of 9 here. Is that right? No. Only 8 can fit in that second shell. That means it requires a third shell. So I have 2 plus 8 is 10. I need 11 electrons to make this a neutral atom, so I am going to have 1 electron in that third shell. Okay, on your next page, if you're checking this, the correct names, P, of course, stands for your protons. N is going to be your neutrons, and E is going to be your electrons. That should be part of your vocabulary for these 3 subatomic particles that are found. Look at the prior atoms. Which atoms have the same number of protons and neutrons? Which have the same number of protons and neutrons? 6 and 6, 8 and 8. So both carbon and oxygen have the same number of protons and neutrons. Carbon and oxygen have the same number of protons and neutrons. So I'm abbreviating. Carbon for the C, O for the oxygen, P for the proton, and N for the neutron. Which of the 3 has a different number? Do a little semicolon here. Sodium, which is Na, has a different number of protons and neutrons. Okay, number of positive charges of protons in helium. For this, you can refer to your periodic table. Okay, your periodic table is, again, the chart, and it tells you the atomic number, and it tells you the number of protons. So if you take a look at helium, helium is element number 2. That means it's going to have 2 protons in it. Carbon is element number 6. That means it's going to have 6 positive charges to it. Oxygen is element number 8. So it's going to have 8 protons in it. Sodium is element number 11. So it's going to have 11 protons in it. So add up all the positive and negative charges for each of the 3 atoms for hydrogen and helium, and also the rest of them as well. So remember, to make something neutral, you have the same number of positive and negative charges. So atoms must be neutral. What's the charge of each atom? The charge of each atom is neutral. Why are they neutral? Take a look at hydrogen. Hydrogen has 1 proton and 1 electron. Positive 1 and negative 1 add to 0. What has to happen in order for an atom to be? It needs to be neutral. How does it be neutral? Well, you have to have the same number of positive and negatives. So you have to have the same number of positive protons and negative electrons. So helium, in order to balance the 2 positive protons, has 2 electrons. Carbon has 6 protons. It has 6 electrons. Oxygen has 8 protons. It will have 8 electrons. Sodium has 11 protons. It will have 11 electrons. The 2 positives and the 2 negatives make 0. The positives and the negatives make 0. Positives and negatives make 0. Positives and negatives make 0. Does having a different number of neutrons change the charge of the atom? No. Sodium, okay, for example, has a different number of neutrons than protons and electrons. What's the charge of a neutron? Does having a different number of neutrons change the charge of an atom? The answer is no. And explain. So write down, what is the charge of a neutron? Neutrons are neutral. Neutrons are neutral. And do not affect the charge. However, neutrons do have a mass, and so therefore they will affect the mass, but not the charge, because they are neutral. Last question. While atoms do not need to have the same number of protons and neutrons, they do need to have the same number of protons and electrons. Explain how this prior activity accounts for the definition of an atom. Atoms are fill in the blank. Because you have the same number of positives and negatives, protons and electrons, atoms are neutral. So the following page is looking at some atomic rules. Okay? Remember, the atomic number is also equal to the number of protons and electrons. The atomic mass is the protons and the neutrons. So let's take a look at this again as a quick summary. The atomic number equals the number of protons, which equals the number of electrons. The atomic mass, here's the mass, is equal to the number of protons and neutrons. Here's the mass. The mass is equal to the protons and neutrons. And we will often be using this formula here rather than this right here. We can calculate the protons any day because that's the atomic number. But these are the two things that are very, very important. Again, the mass is equal to the protons plus the neutrons. So we can rearrange this, and we can subtract from both sides. Oops, we're going to subtract the protons from both sides. So the neutrons is equal to the mass minus the protons, which we get the mass minus the protons. That's where this formula comes. So let's go ahead and take a look at hydrogen. Hydrogen, number of protons. How do I find the number of protons for hydrogen? Look at your periodic table. What's the atomic number of hydrogen? It is 1. Number of electrons must be 1. What's the atomic number? 1. All three of those need to be the same. Now, if you round hydrogen, it will round to 1. So the number of neutrons is going to be equal to the mass number minus the protons. What's the mass number of hydrogen? It is 1. What's the number of protons? It's 1. 1 minus 1 is 0. Yes, hydrogen is the only element that will not have a neutron. So let's take a look at the mass. Here's a mass of 1 plus a mass of 0. 1 plus 0 is 1. So these two numbers, again, the protons and the neutrons, should add to that. Okay, what's the atomic number for helium? Atomic number is 2. That also gives it the number of protons and the number of electrons. The mass number is rounded to, it's 4.0026, which rounds to 4. So you can do it two different ways. 2 plus what equals 4? Or you can go say, what's the neutrons? It's the mass minus the protons. This 4 minus 2 is 2. 2 plus 2 will equal 4. Oxygen. The element for oxygen is atomic number 8. Therefore, it has 8 protons, 8 electrons. The mass number is 16. 16 minus 8 will give me 8, or 8 plus 8 gives me my 16. Sodium is element number 11. Number of protons is 11, electrons is 11. The mass rounds to 23. 23 minus 11 gives me 12. So remember, the number of protons equals the electrons is equal to the atomic number. And the mass, as we talked about here, is equal to the number of protons plus the number of neutrons. Okay, on to the next one. Look at the periodic table and fill in the information. Okay, what is the element that has 17 electrons? Well, if it has 17 electrons, the number of electrons is also the atomic number. So that's going to be 17. This is going to be the element chlorine. What's the symbol for chlorine? It is not CH, it is Cl. The atomic mass of chlorine is 35.453. So this says draw another carbon atom as you did before, but this time add an additional 2 neutrons to the nucleus. When the number of protons of an atom stays the same, but the number of neutrons changes, this is called an isotope. We discussed this in lecture. So I have 6 protons. Number of protons is going to be 6. Okay, going back to my carbon, let's go back to carbon. Carbon has 6 protons and 6 neutrons, but now we're going to be adding an additional 2 neutrons. So how many neutrons will I have? I will have 8. This is not a charged atom. This is a neutral atom. It happens to be an isotope. The electrons have to equal the protons, so the number of electrons is going to be 6. Let's take a look at what this looks like. We're going to draw this. This is going to be 6 protons in the nucleus and 8 neutrons in the nucleus. Because it has 6 protons, it is still going to be carbon. Atom rules. Isotopes have the same number of protons as the element, but have a different number of neutrons. So the same number of protons as the other carbon is going to be 6. We've changed the number of neutrons, so it doesn't change the charge. However, it does change the mass, which we'll get to in 1 second. So let's take a look at the electrons. I have 6 electrons. How many fit in the first shell? 2. How many will fit in the second shell? I need to occupy 6 total. 2 in the first, that means 4 are going to be in the second. Now, what is the atomic mass of your new isotope? Mass. Mass comes from both the protons and the neutrons. It's the weight of the nucleus. So my mass is going to be 14. Elements are named from the number of protons. Did the number of protons change? We went from 6 protons. We still have 6 protons. The number of protons did not change. If the number of protons did not change, what's the name of your isotope? The name of the isotope is carbon. Do you know the technical name for this isotope? Write the answer from number 3 below, so it's carbon. Okay, and then write the answer from number 1 after it. The answer from number 1 is 14. It is carbon-14, often called C14, which is also radioactive carbon. Okay, we took a look at the isotope deuterium. Here's hydrogen, here's deuterium. Let's take a look at tritium. Remember, this is an isotope, so the protons is not going to change. Here it has a mass of 1 because there's 1 particle in the nucleus. This has a mass of 2 because there's 2 particles in the nucleus. I can't change the protons, so the only thing that can change in the nucleus that changes the mass is the number of neutrons. How many neutrons will I have? I will have 2 neutrons. And I will still have 1 single electron like this. So draw another carbon atom as you did before, but instead of adding an additional, so we did this one right here, we have 6 protons, we have 8 neutrons, but instead of adding an additional 2 neutrons, we're going to add 1 proton and 1 neutron. So we're going back to the 6 and the 6. We're going to add 1 proton, we're going to add 1 neutron. Okay, so let's just list this. My protons, protons is plus, neutrons, and my electrons. I'm adding an additional, instead of it, we're going to add 1 proton and 1 neutron and 1 electron. So we're going to have 7, 7, and 7. Okay, so let's put my protons and my neutrons. So I have 7 protons and 7 neutrons. Let's fill in my shell. How many fit in the first shell? 2. How many will fit in the second shell? 2 plus what equals 7? 5 electrons. What element is this? Look at the periodic table. I've now changed the number of protons. Well, the protons is also equal to the atomic number, so I have 7 protons, I have 7 neutrons, I have 7 electrons. My atomic number is now 7. What's atomic number 7? It is nitrogen. What's the atomic mass of nitrogen? If you add your protons and neutrons together for the nucleus, it comes out to be 14. Did the atomic mass change? It changed from this right here, but it didn't change from this right here. So that was not a very good worded question. So did the atomic mass change? It did not change from carbon-14. So the atomic mass change, we should probably say, compared to C14. So let's take a look at C14. C14 has a mass of 14. So no. Did the atomic number change? Yes. We have the same mass of 14, but the atomic number changed because the number of protons changed. Even though the atomic mass is the same as carbon-14, since the number of protons change, we no longer have carbon, we have a different element. What's the name of this new element? It is nitrogen, and we can call it nitrogen 14. That concludes this key.